Okay, so to start, we're gonna review shell and Lewis structure stuff from last time. So we're looking at oxygen. So if we go on the periodic table and we look for oxygen, first thing we want to do is find out how many shells it has, right? So if you guys remember from last time, the row that the element is on is going to determine how many shells it has. So oxygen is in the second row, right? The first row is this one right here, and then oxygen is the second. So it's gonna have 2 shells. So for our drawing, our shell model, we're gonna draw the nucleus, which is just O, and then we'll draw 2 shells around it. So 1, 2. And on the side, we'll write 2 shells. All right, let's fill in the shells with the electrons. So if you guys take a look at oxygen, it's going to have 8 electrons because it has number 8. It's also the protons. So let's just start by writing that down. So it's going to have 8 protons and 8 total electrons. Okay, just remember, these two values are the same. Okay, the first shell is going to contain 2 electrons. So we're just going to draw the 2 electrons. And then the second shell is going to have 6 electrons for a total of 8. So if you guys got anything similar to that, where you have 2 electrons in the first shell, 6 on the outside or the valence shell, then great job. That's pretty much what we went over last time. All right, now if you guys remember, this last shell is the outside one is the one that we call the valence shell. And so if for the valence electrons, there are 6 valence electrons, and that'll help us draw the Lewis structure, which is going to be O, and then we put 6 dots around it. All right. That's it. That's pretty much what we went over last time. We talked about how many shells an element has, how many total electrons, and how many valence or the outside shell electrons. All right. Any questions on the review? Hopefully it's not too bad. All right, so today we're going to be talking about something called ions. And one note I do want to make before we move on is that from now on, the protons and the total electrons, they're going to be different. Okay, so starting today, they're going to be different. You're not going to use the same number for the protons and the electrons starting today. But I'll show you guys how to calculate all that. The math is pretty simple. But yeah, just wanted to give you guys a heads up. Alrighty, guys. So let's get into the new information. Today we're learning about something called ions. And again, don't write down everything I'm going to pull up on the screen. I'll tell you guys what's important. So up until this point, we've been talking about neutral atoms, right? It's where you have the same number of protons and electrons. However, today we're going to talk about these things called ions, and I do want you guys to write this down. Okay, the term that we're working with today is ions. And ions are compounds that have an electrical charge. You guys don't need to write the first definition, but I do want you to write down the second one right here. And the key thing is that they have an unequal number of protons and electrons. Okay, so now the protons and the electrons are not going to be the same. Okay, so make sure you guys write this down. We're learning about ions now, and this is when you have an unequal number of protons and electrons. So today we're learning about ions, and that's when you have an unequal number of protons and electrons. All right, so down here we have 3 examples of some ions, and this is the way that we write ions. So we talked about how to write the element's number, right? And I think last week we learned about isotopes, where we put the mass number on the top left. But today we're going to be talking about this thing that goes on the top right. If you guys notice, there's a plus sign, a minus sign, and a 2+. Okay? So on your paper, I want you guys to write this down right here. Just copy down NA, and I want you guys to put that plus sign on the top right. Okay? And this number, or this thing on the top right, this tells you the electrical charge. Okay? It tells you the electrical charge of the ion. Okay? It's basically telling you what kind of electrical energy it has. Does it have positive energy or negative energy? if there's just a plus sign and just a minus sign, it just means 1. So +1 or -1. But if there's a number next to it, that means it has a charge of +2 or -2 and so on and so forth. Okay. So if you ever see just plus and minus, it just means 1, but we can have numbers associated with it. Yeah, what's up? Just the Na is fine. Just to notate that this is the electrical charge. And I'll show you guys how to calculate the positive and the negative energy and stuff like that. But I just wanted to go over what this is. Any other questions? Okay, so let's talk about why this is important first of all, and then we'll talk about the actual calculation. You can go ahead. Thank you. Okay, so let's talk about why this matters. So ions, these charged particles, okay, you guys don't need to write this down. They're commonly found in water and other liquids, okay? And as you guys know, you guys are mostly made of water, and so there's a lot of ions inside of your body as well, okay? Ions are actually how your body's cells talk to one another. Okay, basically, all of the nerve transmission, so you listening to my voice, going through your ears, going to your brain, processing it, and then you copying stuff down, all of that is a result of your cells talking to each other, and they use ions for that. Okay, and because your body runs on basically ions, too much or too little, or having ions that don't belong in your body, they can be deadly or make you sick or have really bad repercussions. Okay, so today during your assignment, you're gonna watch a video where you're gonna learn about something called the Flint, Michigan water crisis. Have you guys heard about this? It's from like 2011, 2012. But basically, what happened is there's a city in Michigan called Flint, and they pretty much changed where they got their water from. Okay, they changed it to the Flint River. And this is what the water in the hospitals look like. So as you can see, this hospital is supposed to be the cleanest place, and the water coming out of the sink is disgusting, okay? So let's talk about what caused it. So I'm gonna give you guys 2 of the answers for your assignment today. So what caused the Flint water crisis, okay? They had a change in water source, okay? Okay, so I want you guys to write this down in your notes. You can just write down number 2, and then you can just write the answer, change in water source. So the city, they changed where they got their water from. All right, now, when they changed where they got their water from, it affected the pipes that they use for the water. And as you guys know, most water pipes are made out of metal, right? Okay, now Flint's water pipes were made out of 2 different metals. The first one is lead, Pb, and the other one is Fe, or iron. Okay, so we have lead and we have iron. And pretty much what happened is as they changed their water source, the water went through the pipes. And what they did was they started pulling the metal out of the pipes into ions. And so you had a bunch of lead ions and iron ions inside of the water. And I don't know if you guys have heard this before, but lead is poisonous for our bodies. And so the water in the pipes started pulling lead out of the metal pipes, and they started coming into the drinking water. A lot of people got really sick. A lot of people had some permanent disabilities because of this. And so this is why ions matter, because if we don't know anything about these ions, we don't know what's happening as we pump water from our water sources into our homes and into our bodies. And so you're going to watch that video. There's some questions on your assignment about it. But this is pretty much why it's relevant for us. It's because it affects something that we use every single day in our lives. Okay, so with that very depressing thing out of the way, let's go into the actual calculations and things like that. Something a little bit more little emotionless. So 2 other definitions you'll need to know are cations and anions. Okay, so you do need to write this down on your paper. Okay, cations are ions with a positive charge. Okay, so cations have a positive electrical charge. Okay, what that means is they have more protons than they do electrons. Okay, so cations are ions with a positive charge. They have more protons than they do electrons. Okay, the second type of ion is called an anion. And these are ions that have a negative charge. And it's the opposite of a cation, right? Positive and negative energy is opposite. And this is where you have more electrons. God bless you. This is where you have more electrons than you have protons. Okay, so we got cations and anions. Cations are positive ions, and anions are negative ions, okay? Easy way to remember this, if you guys like cats, cats are positive, okay? And Anne is the name of the girl that broke my heart in kindergarten, so she is negative, okay? So boo Anne, Anne is negative. Okay, so cats are good, Anne is bad. Remember that. There's no Anns in this class, right? Okay, great. So cats are good, Anns are bad, positive and negative. Alrighty, so with that being said, I'm gonna show you guys now how to calculate how much positive or how much negative energy an ion has. It's pretty simple. You just need one formula. It's very similar to the one that we learned last time, but let's get into it. So we're gonna be looking at number 4, and on your paper, I just want you guys to write number 4. And today we're gonna be looking at Mg, so I want you guys to write down Mg. And we're gonna be looking at an Mg ion with 10 electrons. Okay, so on your paper, I want you guys to write number 4. We got an Mg atom with 10 electrons. Okay, so let's start by doing the first part of the problem, which is you're finding the charge. Okay, we're gonna find the charge on an Mg atom with 10 electrons. So let's find the charge first. So the first part of this problem is going to be the charge. So we're basically trying to figure out what the positive, whether it's positive or negative, and how much positive or negative energy it has. All right, now, if you guys take a look at this formula, it'll tell you guys how to find the charge. It's very simple. The charge is equal to the protons minus the electrons. Okay, the charge is protons minus electrons. Okay, so I want you guys to go on your periodic table. I want you guys to figure out how many protons magnesium has. And then I want you guys to use this formula to calculate the charge. I'll give you guys about a minute to do that, and then you can check with the person next to you. But I want you guys to find the protons for Mg on the periodic table, and I want you guys to calculate the charge, and then write it down on your paper, and you can check, okay? I'll give you guys a minute to do that. Alrighty, guys, so let's look at Mg on the periodic table. It's gonna be on the right side. If you guys look at Mg, hopefully you guys identified that it has 12 protons, okay? So on our notes, we're gonna write down that Mg has 12 protons, okay? Now, the charge is protons minus electrons, so we're gonna do 12 protons minus 10 electrons, and that's gonna give us a charge of positive 2. So if you guys got positive 2, great job. For the charge, you have to write if it's positive or negative. Okay, so just make sure you guys include that. If you just write 2, I believe on your Canvas quiz, it'll be marked wrong, and the TAs will mark it wrong for your assignment as well. So positive 2. Okay. Any questions on that? Hopefully not too bad. Yeah. You will, and I'll show you guys that in a sec. Yeah, if you wrote 2 plus, that's fine as well. Okay. In fact, 2 plus might be more helpful when we do the symbol. Good catch. Okay, so if it's positive 2, is this a cation or an anion? Cat, yeah, right? Cats are good. An is bad, but cat is good. So this is a cation. And then to write the symbol, very simple. We're going to write the symbol for the element, which is Mg. And then you take the electrical charge and you put it on the top right, but you always put the number first, so it'll be 2 plus. If you write plus 2, I mean, technically you're incorrect or correct, but we're going to mark it wrong because chemists always do the number first. So just because we want to follow what the nerds do, we're going to write 2 plus, okay? So just make sure you put the number before you put the sign, positive or negative. All right, any questions on that? We just have 2 more practice problems and then we're all done for today. Alrighty, so we're gonna move on to the next problem if you guys don't have any more questions. Okay, on your assignment, you're gonna see a chart that looks like this. And I'm gonna have you guys try 5 and 6 on your own. But how about you? Before we do that, I do want to mention one thing. This is combining what we learned from isotopes with what we learned today. If you guys look right here for number 6, for complete symbol, if you look on the top left, this is going to be the mass number. So just look back at your notes and hopefully you guys can find how to find mass number right here. And then this right here is going to be your charge, which we learned today. Okay, so I do want to give you guys some time to try to figure this out if it's a little difficult, or you can work with the person next to you. I'll give you guys about 4 minutes to try number 5 and 6. We'll go over them together, and I'll get you guys started on your assignment. Okay, so good luck, guys. If you have questions, let me know, but you guys have 4 minutes to work on these 2. All right, so again, Cl, we find that because of the protons. It's 17 protons. That tells you that's chlorine. We got the mass number by doing protons plus neutrons. So 17 plus 20 gives you 37. And then what we learned today, the charge is protons minus electrons. So 17 minus 18 is -1. So we just write a minus sign on the top right. Okay. All right, any questions? Hopefully not too bad. The math is pretty simple. All right, let's go to number 6. And this is the one that I think is a little more tricky because we need to work backwards. But let's start with protons because that's the one that's always really easy to find. Okay, so we have W, which is tungsten. So we go to the periodic table and we look for W, which is right here. And it's going to have 74 protons. Okay, so we're going to write 74 for the protons. Okay, so if you guys want to write down how we know this, we know it's W. So that means it's always going to be 74. Okay, so always 74 protons. Okay, next one, let's do the mass number because you guys should remember from all the practice we did for this. Mass number is protons plus neutrons. So if we want to find just the neutrons, we take the mass number and we subtract the protons. Okay, so 141 minus 74. If you guys want, you guys can pull up your calculators, but 171 minus 74 is going to be 67. So we have 67 neutrons. And again, you can always check your answer by adding the 2 numbers together. And that's going to give you your mass number, which is 141. All right, any questions so far? This is all review, at least for number 6 so far. Okay, let's do the charge now. Now, if you guys remember from today, charge is going to equal, I'll write it right here. Charge is equal to protons minus electrons, okay? So if we take a look at this problem, the charge is just a plus sign. That means the charge is +1, right? Okay. Now, we already know protons is 74, so we have 74. So 74 minus the electrons is going to give us +1. So if we just think about it, what do we need to subtract from 74 to get 1? 73, exactly. So your answer is 73. Easy way to look at it is if you take the charge, 74 minus the charge, which is 1, is going to give you 73. And again, you can always check your answer. 74 minus 73 is +1. Okay? So if you want to do the algebra and move the electrons to the left and then subtract by 1, you guys can do the algebra if you want. Or you could just think about it logically and just try to get the charge. Okay?